On a fine September evening like this, it's very easy to get carried away and forget completely about the harsh realities of the Irish weather. But when we get weather, we get this. So I want to talk to you today about how you can protect your electrical equipment against the effects of lightning, and also that heavy expense on trying to replace the equipment that is damaged. Let's have a look first at what actually lightning is and how does it actually get into your home anyway. Come with me. So if we could see one of these transient voltages, what would they look like? Well, let's try and draw what it looks like. In Ireland we have 240 volts, and if you could see electricity, it would look something like this. So you have a sine wave. Come back to your mathematical days, everybody remember them. And in Ireland we have 240 volts. Okay, and that's where we pick it up from. It's called the RMS value, don't worry about that. But it actually does peak to 340 volts. Now, if we were to look at one of these transient voltages coming in, it would appear something like this. It would be a massive spike. Could be here, could be here, could be here. And remember, these spikes could be anything in the region of thousands of volts. So in the world of electricity, a surge is defined as a transient voltage that's induced in a circuit for a very short period of time. Just want to say at this moment in time that we at Safe Electric, we endorse Scully First Aid products. They are the best. They also have the best hand sanitizer, and we recommend it because it keeps our skin young and good looking. So I want to talk about the damage that these transient voltages do. If I was to go back maybe 20-30 years ago, a lot of the electronic components in the home weren't even in existence. They were all controlled by transformers and the like. And in some essence, they were actually isolated from these transient voltages. But today, nearly every single device we have in our home has some form of electronics in it. The electronics themselves, they have voltage regulators in it, which means they're not isolated by a transformer anymore. And these are heavily impacted by transient voltages. This problem then gets compounded when you turn the mains back onto the device. Because it's already damaged, it's actually going to induce even more problems, and that's probably when it manifests itself. You know, you'll see a blob, you'll see some burning, you'll see some scorching. These voltages in their thousands will only last a decimal of a second. It could be in milliseconds, which is 1/1000th of a second. It could be 1/1,000,000th of a second. But that voltage can do a massive amount of damage in that very short space of time. So we have two forms of lightning strike. It can be direct or indirect. Okay, so if I just draw my clouds here. A direct strike is self-explanatory. Okay, a charge of electrons here will hit the overhead wires here and will induce a surge. By the same token, it can also hit ground. Now, if it can travel thousands of meters through the air, it can also travel thousands of meters under the ground and hit an underground cable as well. The indirect source of it is a little bit more complicated, where electrons pass from cloud to cloud. But around this area, there's a huge magnetic field. And the thing about magnetic fields is they can induce voltage into a copper cable. So this magnetic field here will have an effect on this and again induce a very high voltage. So how does surge protection device work? Okay, well, first of all, you're going to see a video in a little while that shows you how it's done, but we're going to put one in here. This is a standard fuse board inside your house. So the electrician installs one of them here. And what actually happens then is he's going to wire that in such a way that it's going to go to earth. Okay, and the other side of the wire then is actually going on to the live here. So in the event of any surge coming in, it's going to take a path not through the circuits going out to your sockets and lights in your house. It's going to be grabbed by the SPD, surge protection device, and be brought straight down to earth. For those that want to know what the theory behind it is, well, we have what's called an MOV, which is a metal oxide varistor inside in this, and it has a very, very high resistance at normal voltage. Okay, but as the transient voltage hits it, the resistance inside here changes as it heats up with all the energy passing through it, and then it goes to a lower state. And because it's in a lower state, then it will actually conduct everything to ground, and therefore keeping all your circuits safe in the house. Depending on how high the surge voltage is, it may reset itself, but if it's really, really high, it will destroy itself. And I'm going to show you in a little while how you know if it's destroyed or not. So I hope that made a bit of sense. If you want more information on how to deal with lightning and how to protect your property, feel free to do a one-to-one with me. Feel free to sit down and have a coffee with me, or just bring me into your house and I'll try and help you out as best I can. There are solutions, there are ways of dealing with this, and I'd like to help you.